Welcome to Best Load Software, the most sophisticated unit load design and structural analysis software available. Best Load has three primary sections: input for design, view edit to evaluate the design, and analyze for specifications and structural analysis. The design process begins with the pallet and storage and handling conditions, then the design of the distribution packaging system or bulk product, followed by the shipping. Because the pallet design procedure in Best Load mimics the procedure used in Best Pallet software, the pallet design input process will be demonstrated using Best Pallet. The design process begins with either a stringer style or block style pallet. You can begin the design process by selecting one of the two buttons at the bottom of the screen or the next button. On the pallet styles input screen, the user is able to select either a pallet or skid style, two-way or partial four-way, reversible or non-reversible, flush, single-winged or double-winged, new lumber, a combination of new and recycled lumber, remanufactured, or repaired. On the lumber input screen, the user is able to specify the lumber species mix, lumber grade, and moisture content associated with the desired pallet design. Component groups can be separated by using these buttons or by manually dragging and dropping. Once component groups have been separated, in this drop-down menu, you will see you have the ability to specify a lumber species mix of up to 3 different species and the percentage breakdown of each for each component group. Furthermore, the user has the ability to separate exterior and interior components using the checkboxes here. Used and recycled material can also be specified with all species, all hardwoods, or all softwoods. And the lumber species selection map can be used to filter the desired species for a particular region. On the stringer input screen, the user is able to specify the quantity of stringers, the uniform stringer height, the width of each stringer, and if partial four-way, the dimensions and locations of the notches. Users are also able to specify the location of stringers either manually or numerically. Staggered fastener placements as well as asymmetric stringer design are also options. On the top deckboard input screen, the user is able to specify the quantity of deckboards, the width of each deckboard, the number of fasteners per connection, the uniform thickness of the deckboards, and locations either manually or numerically. End boards can be butted, corners can be clipped, and asymmetric top deckboard design is available. A lip can be added to the pallet design where the end boards overhang the ends of the stringers. On the bottom deckboard input screen, users are able to specify the quantity of deckboards, the width of each deckboard, the uniform thickness of the deckboards, and the number of fasteners per connection. Deck board positioning can be done manually or numerically. Bottom deck boards can be chamfered, and asymmetric bottom deck board design is available. Once a pallet design has been completed, the user has the ability to specify the specific fastener being used as well as predict the pallet durability. The fastener type can be selected from the drop-down menu, and once chosen, the fastener data can be input into these fields. If the MyBand angle is unknown, it can be designated based on the wire diameter. Different fastener specifications can be entered for the top and bottom deck, and for block pallets, mat fastener specifications can also be input. Once a fastener specification has been completed, it can be saved to a durability file that can then be retrieved for use with future pallet designs. Once pallet cost has been input, a durability assessment can be performed, predicting the cycles the pallet can withstand prior to its first repair, as well as the number of cycles the pallet is predicted to withstand after properly repaired, in addition to the relative damage rate and relative damage severity, which are clearly explained by clicking on the check mark box. The storage and handling conditions input screen allows the user to specify the specific ways the pallet will be supported and handled throughout the intended supply chain. This includes free-span racking, warehouse floor stacking, and handling with forked equipment. The checkboxes to the left of each support condition enable that support condition as part of your structural analysis. So be sure not to check mark any that do not apply to the specific or intended supply chain. The checkboxes to the right of each support condition show you the three-dimensional portrayal of the pallet in that support condition. This, of course, includes warehouse floor storage and handling with forked equipment in both directions. For each of the support conditions, the free span and the bearing area can be adjusted, as well as for forked equipment, the length, width, spacing in between, and thickness of the fork tines. Block pallets can be designed by first entering the length and width, the use category, and the treatment for export. The style of the block pallet bottom deck is chosen between perimeter, unidirectional, overlap, reversible, and skid. Simply check mark the associated box for the design preferred. If the user needs to reorient the bottom deck 90 degrees relative to the top deck, simply use the turn button. The lumber input screen functions the same way as the stringer input process with an additional component group. The quantity of blocks can be specified from 4 to 36, simply by check marking the box associated with the quantity desired. Block dimensions can be specified, including the uniform height, the width of each block, and the length. Asymmetric block design options are available relative to the length or width of the pallet. Block locations can be specified, including wings and cantilevers. You can see now this perimeter-based block style pallet has a 2-inch single wing and a 2-inch single cantilever. Stringer board dimensions are specified, including the stringer board thickness and the width of each stringer board, as well as the location. The top deck board input screen functions the same way as the stringer input screen, aside from now the user has more than one type of fastener. After the top deck board dimensions, quantities, and locations are specified, the user then has the ability to specify the quantity of fasteners per type of fastener connection. The bottom deck board input screen functions similarly to the bottom deck board input screen for stringers. However, in this case, it is a perimeter-based style block pallet, where the width of the butted boards can be specified, as well as the end board width and the uniform bottom deck board thickness. Finally, the user is able to specify the quantity of fasteners per connection for their block pallet design. Fastener specifications can be input similar to stringer pallets, where a different fastener can be specified for the top and bottom deck boards. However, mat fastener specifications are also possible for block pallet designs only. And storage and handling screens are the same for block pallets as they are stringer pallets. Now that the pallet design has been completed and the storage and handling conditions have been specified, the user has the ability to click on the packaging icon. Here, you will find 9 different distribution packaging systems or bulk products that can be used to design the load on the pallet. If you do not see a particular packaging system here, bear in mind that so long as the geometry is similar, you can model that packaging system or product using one of these options. For all of these options, the applied compression stress is predicted once the packaging or product is designed and geometrically oriented to the pallet surface. For corrugated containers, BestLoad will also predict the compression strength. I will begin by demonstrating the corrugated inputs. The user first has the ability to specify either external or internal dimensions, the weight of the corrugated container with the contents, the empty weight, the product supported weight, which accounts for the structural integrity of the primary packaging or contents within the distribution package. If there is headspace inside the box between the contents and the top lids, this is to always remain 0 pounds. If there is no headspace, this is never to remain at 0 pounds, because the user knows the contents are supporting some of the compressive load. Flute styles are available for double wall, single wall, and triple wall. different styles of containers, from slotted to telescoping to bliss to trays. Various dividers can be added to the corrugated container, shown here. And below, we begin to model the geometric fit attributes of our packaging system on our pallet. How many packages per layer? To increase the maximum, the user must allow overhang of the packaging relative to the pallet. And if there is a quantity less than the maximum desired, it can be entered in the desired field. Furthermore, how many layers of packages per pallet or unit load? Is there a height requirement for the overall unit load? And do we want to adjust the number of unit loads being stacked in warehouse floor storage? Next, the user is able to specify the specific board grade associated with their corrugated container. Here you can see you have the ability to specify either a regular or performance-based board grade for the liners and medians of this single wall C-flute container. Units are provided in US pounds per 1,000 feet squared or grammage metric units. If the user is unaware of the specific board grade, it is recommended that the box manufacturer's stamp on the actual box be looked at to find the ECT value. Once the ECT value is known, it can be entered into this specific drop-down menu, and Best Load will automatically generate the most common average board grade associated with the single wall C-flute 40 ECT container. In the lower left-hand corner, you begin to see performance outputs that will be explained in more detail on coming screens. A safety factor is generated for the intended supply chain and the associated degradation factors. Most importantly, the amount of humidity and the storage time duration. As these degradation factors are modified, the safety factor is adjusted accordingly and applied to the calculation used for corrugated compression strength. Here, the user is provided with specific definitions of each of the outputs associated with corrugated compression strength. Here we can see this particular box is significantly over-designed. Stacking patterns can be defined either column stacked or interlock stacked. And if interlock stacked, the user has the ability to interlock specific layers or in pairs, trios, etc. Specific load stabilizers can be selected for a unit load design, which include load stiffness adjustment factors associated with the performance of each. Load variability as well as material costs can also be specified. For all other packaging systems, dimensions are entered, as well as capacities, masses, materials, and of course, quantity of packages per layer, quantity of layers per pallets, and if we're adjusting the stacking height. Stabilizers, load variability, and any material costs can also be specified. In the case that a user simply wants to design a pallet with a general uniformly distributed load, the general packaging input can be selected. Any underhang of the load relative to the pallet can be entered on the left-hand side, in addition to the stabilizers, load variability, and associated costs. Once a unit load design has been completed, the user is able to select the shipping icon and then a specific shipper. A default load limit will be generated, in this case reflecting the 80,000 pound load limit for US interstates. The user may edit the load limit in the case of a permit or international shipping. For full truckload shipping, the user is able to select from layouts generated by the algorithm. For less than truckload shipping, the user is able to drag and drop unit loads into position as well as adjust the stack height quantity with the arrow keys on the keyboard. For mixed truckload shipping, this button is to be selected, and after the shipper is selected, the user will populate the unit load files one by one in the order in which they are to be loaded into the shipper. Once the menu has been populated here, for each of the unit loads, the user can designate the desired quantity of unit loads here, as well as any stack height limitations. Now that the input section of the software has been completed, the user can navigate to the View Edit section of the software. Here, the stacking pattern can be adjusted according to the algorithm-based results. The stacking pattern can also be adjusted for only the first layer and then extrapolate upwards to the full unit load. For all rectangular-based packaging systems, designing a custom load layout is also an option for the user. This can be done in cases where the algorithm does not pick up a particular stacking pattern. Additionally, all orientations of a rectangular package can be provided as well for custom stacking patterns. In the pallet view edit screen, the image of the pallet can be adjusted manually. And in the lower right-hand corner, corner support can be evaluated, as well as which packages are under the highest stress, according to this explanation provided, where the highest static stresses are most often in warehouse floor storage. Best load models both interfaces. When corners are unsupported, they will appear red, creating a concentrated load on the packaging system. Critical bearing area for those packages under highest stress, as well as stress distribution. Stencils and stamps can be applied to the pallet here. View Edit can be used to evaluate the box as well as adjust the coloring. And in the shipping View Edit screen, algorithm-based solutions can be used to generate the optimal load layout. Finally, all View Edit screens can be printed to a physical printer or a document writer. Once the Analyze button is selected, the user has the ability to input company information that will appear at the top of all output screens. In the analysis section of the software, various screens and specifications are provided, including a general overview, a unit load output screen. For the pallet, A three-dimensional specification is provided with custom note fields at the bottom, in addition to a two-dimensional specification with custom note fields on the right-hand side. Two-dimensional schematics, the structural analysis, which provides the predicted maximum safe load or strength, initial average deflection or stiffness, and critical component for each of the support conditions designated by the user. The critical support condition is compared to the payload. Fundamental alternate pallet design suggestions can be generated using this feature. A cut list can be generated for production runs of pallets and breaking down pallet pricing information. If a fastener specification was input, it is also provided, in addition to pallet durability. A durability comparison feature is provided where the user has the ability to either compare the same pallet design with two different fastener specifications or two different pallet designs. Box analysis screen providing the target and predicted compression strength, in this case indicating our box is over-designed for its intended use. Shipping output, as well as sustainability metrics. All analysis screens can be printed to a physical printer or a document writer, whether individual screens are selected and print selected is selected, or all screens are printed.